Yes, we are live now. Please start.
Yes, sir. Thank you. Hello everyone. In this second live interaction session of the course Variational Calculus and its application in Control Theory and Nanomechanics, let me start with an introduction of this course. This is an introductory course to the theory and applications of variation calculus to problems in geometry, differential equation, physics, and mechanics. The most important part of this course is it serves as a reference for advanced study and research in this subject, as well as for its applications in the fields of industrial control system and nanoscience, etc. In the last live interaction section, we have discussed till week 4, that is till isoperimetric problems. Thus, I will be continuing from week 5 to week 8. So you can ask any doubt from this section. So let me wait for some time to attend your doubts from any of this section. So I guess nobody has joined. So let me wait for some time. I will be continuing from week 5 to week 8. So you can ask. Student, please join the session. If you have any doubt, please ask me. Or maybe I can do one thing that by the time you think or ask your doubt, let me recall or discuss few few contents from week 5 onwards. So in week 5, in this section, our professor has discussed about problems with holonomic and non-holonomic constraints and variable endpoints, right? So now, what is holonomic constraint, or it is also known as algebraic constraint? So it is nothing but, so if you have a condition like suppose g is a function of t comma q bar, which where q bar is q1 comma q2 and up to qn, where n is greater than equal to 2. If this function is 0, this function contains the variable t and q bar. Remember this one. So then this constraint is called holonomic constraint. And for non-holonomic, or which is also called differentiable constraint, is nothing but the function which contains the variable t, q bar and q bar dot equal to 0. So it contains a differential factor, right? So this is called non-holonomic constraint. So one important point I would like to mention here, that class of non-holonomic constraint is widespread in mechanics, but it is avoided as Hamiltonian's principle is not applicable in this case. So please remember this one. And for the next one, for variable endpoints, so here, like before, we have that we have x and y values, right? X is fixed, y was fixed, but in this variable endpoints we have x fixed but y is a variable. So in this case, what we can do is we can replace this fixed point condition at x1 comma y1 with the condition del f by del y dash at x naught is 0 and del f by del y dash at x1 equal to 0, along with the Euler-Lagrange's equation. So if we can use this one if there is no fixed boundary condition are given, and this is applicable when the functional contains only first order derivative. Now, if the functional contains second order derivative also, so then the condition will be del f by del y double dash at x naught equal to 0 and del f by del y double dash at x1 is equal to 0. And the second condition is ddx of del f by del y double dash minus del f by del y dash at x naught equal to 0 and also at x1 is equal to 0. So here I would like to take some question or doubts if you have any, and also I would like to wait for the student who would like to join the session. So in the YouTube live section, I can see one of you have questioned that if this lecture is for BTech first year or not. So this lecture is you can obviously avail in your first year also, BTech first year also. It is very helpful and it has vast application also. So you can definitely avail if someone is in first year of their BTech. Any other question? The lecture is structured in such a way that if someone is learning calculus or something like in their 12th class, and then directly they are learning from their first year, so this session is very very useful to them. So you can obviously avail this course. You can do this course. This is very helpful. This is very helpful. Okay. So moving on to our next week content, that is week 6, which which is about broken extremal and variable boundary points. So in variable boundary points, so initially, not initially, like in last week, so we had that x was fixed but y was a variable, right? So now we have both x and y which varies. So in this case, we have this Euler-Lagrange's equation for sure, but secondly, we have this another condition which is p del del y minus h del del x at x not equal to 0 and also at x1 equal to 0, where p is nothing but the del f by del y dash, which is momentum term, and h is y dash del f by del y dash minus f, which is Hamiltonian term. And the professor also discussed about the transversality condition in this week. So this transversality condition is also very important. Okay. So moving on to this broken extremal. So these extremals are broken extremals are those which are like continuous but may not be continuously differentiable. So in order to get an extremals, we need to have a condition for which we can find an extremal or extremals which can connect the boundary points, which are all at most piecewise continuous. So in this broken extremal, so our motive should be we need to find a condition for which we can find an extremals which can connect the boundary points which are at most piecewise continuous. And also the professor had also discussed some problems of Newtonian aerodynamic problems and Hamiltonian formulation. So in this course structure, so you can find lot of example which clearly explain the method, the theorem, the procedure of the problem or the subject. So please go through the example thoroughly, so you will understand the content easily. So moving on to the week 7 content, which is about Hamiltonian-Jacobi equation and its examples and some theorems. So this Hamiltonian-Jacobi equation is nothing but the first order nonlinear PDE whose solution gives generating function phi. So whenever you see a first order nonlinear partial differential equation, then you can think of this Hamiltonian Hamiltonian-Jacobi equation to solve such kind of PDEs. And you will get the solution in the form of a generating function. So, so in week 7, so we have discussed about this Hamiltonian-Jacobi equation. So let me check if you have. Okay, so there are no more doubts, I can see. So
Yes, we can close if nobody is joining. We can close. You can just give a conclude remarks. We can close.
okay, sir. Okay, sir. So I'll just talk about this last week and then I'll conclude. So, so in this week 8 content, so we have this variational symmetry and Noether's theorem. So the elaborative theorem or the proof I am not discussing here, but the gist, or I mean, in one line, I would like to, explain this Noether theorems, which is nothing but, so this theorem says that, so it links conservation law with the invariance properties of the functional. So this theorem, tells you that it links between this conservation law with the invariance properties of the functional. So that's why this Noether's theorem is also important in our study. So please go through all the contents, and if you have any doubts, so you can, always ask us. You can write to us. So okay then. So today I have discussed from week 5 to week 8 content. So please feel free to ask any question. So with this, I would like to conclude my talk here. So again, I'm saying that if you have any doubt, any question, please feel free to write to us. You can email us, or you can, join the live interaction, the next live interaction section, to, so that we can discuss your doubt. Thank you so much.
Thanks. I will close the session. Thank you for that.
Yes, sir. Thank you so much. Thank you.